Hello, the topic of a presentation is MIPI and today I, Khatia, Nikuradze, and Giorgi Zirakashvili will try to let you know more about the topic. Now, what is MPCSI? It is a widely adopted, simple, high-speed protocol primarily intended for point-to-point image and video transmission between cameras and host devices. MIPI-CSI1 was an original MIPI interface for cameras. It defines architectural interface between a camera and host processor. MIPI-CSI2 stands for Camera Serial Interface Second Generation. It is the most common interface for mobile applications, is used to connect smartphone camera modules to an SoC. All the SoCs provide up to 6 serial lanes which can be used to connect one or more cameras. Each of these lanes provide bandwidth of up to 300 megabits per second, which allows high-resolution camera modules to operate at high speed. Next is MIPI-CSI3, which uses 32 virtual channels and packet-based transmission. It supports in-band interrupts. It also offers signaling rate up to 5.8 gigabit per second per lane. It is backward compatible with earlier versions of MIPI-CSI interface. Here we have quick facts about MIPI-CSI, its advantages, which will be discussed more in detail later. Fundamental features, which are high performance, low power, and EMI, which also we will talk about later, and physical layer, which consists of MIPI DPHY and/or MIPI CPHY. Next, we will talk about how MIPI-CSI is used. MIPI-CSI2 is primary interface used to connect camera sensors to application processors in systems such as smart cars, head-mounted augmented and virtual reality devices, camera drones, Internet of Things appliances, wearables, and 3D facial recognition systems for security and surveillance. Since its introduction in 2005, MIPI-CSI2 has become the de facto specification for mobile devices. With each new version, MIPI Alliance has delivered crucial new functions driven by emerging imaging trends in mobile. According to Joel Hulux, the chairman of MIPI Alliance, CSI2 version 3.0 is the second installment in a three-phase development plan through which they are effectively developing the imaging conduct infrastructure to enable machine awareness through sight. Our lives will be enlarged as they better enable machines to assist us, and MIPI Alliance is developing the infrastructure to realize that future. MIPI-CSI 2 version 3.0 introduces three key new features. First is United Serial Link for encapsulating connections between an image sensor module and application processor. The capability is crucial for reducing the number of wires needed in IoT, automotive, and client products for productivity and content creation, such as all-in-one and notebook computers. Next, we have a smart region interest for analyzing images, inferencing algorithms, and making better deductions. This capability could enable machines on a factory floor, for example, to more quickly identify potential defects on a conveyor belt, or it could enable medical devices to more surely recognize anomalies such as tumor. Next in line and the last one is row 24 for representing individual image pixels with 24-bit precision. This capability will enable machines to make decisions from superior quality images. An autonomous vehicle, for example, could decipher whether darkness on an image is harmless shadow or a pothole in the roadway that could be avoided. Next in line, we have how MIPI-CSI works. MIPI CSI2 is an efficient, low-power, low-pin count interface between image sensor and application processor, meeting the needs of multi-megapixel cameras. MIPI DPHY provides a high-performance serial differential interface, offering up to 4 data lanes with a total of around 4 gigabit per second, plus common differential clock lane. A separate I2C component interface is used for camera control functions. The Cci2 interface supports a variety of data in color space formats, encapsulates transferring packets, lane management, error detection, and correction.
Now I will talk about advantages and disadvantages. So it is widely used in mobile devices. It offers high performance and it also consumes low power. It has a lower pin count and hence reduces EMI and PCB space and complexity issues. It is very simple interface protocol. It offers high bandwidth to support increasing frame and resolution. It supports reusable and scalable protocol stack. It offers improved reliability and lower system cost. Also, it is faster than a USB 3 interface, and it can handle video from 1080p to 8K and beyond due to its low overhead. And it uses fewer resources from CPU due to multiple core processor support. Now about drawbacks and disadvantages. So it supports cable length of less than 30 centimeters, which is less compared to USB 2.0, which has 5 meters support, and USB 3.0, which has 5 meters support. Plug and play is not supported, unlike USB interface, and cost of manufacturing is medium to high. USB manufacturing cost is low compared to CCI interface. It is essential to have a driver for the targeted camera. Otherwise, extra development efforts are required to develop the driver and software protocol stack. This will be time-consuming and expensive. And now let's talk about different types of bridges. Let's start from cable length. So for a stable connection, maximum cable length you get is around 30 centimeters, which is way too short when you need a camera to be placed far away from host. Also, compatibility is issue. If a portfolio of Cci2 cameras ideally meets your application requirements, yet your hardware of choice does not offer a Cci2 or any camera interface, there will be extra work on both the software and hardware side. As a result, you will have to face delays. Length and compatibility issues are all fixable. We do this by converting Cci2 into other interfaces. You can use cameras with higher specifications on any unsupported hardware and have plenty of time on proof of concept development and potential future maintenance works. Being flexible enough on the interfaces also gives you more control over the budget. Now let's talk about different types of bridges. The following converters, which you can see on the slide, can extend the length limit or help transform it into other protocols, or help merge multiple cameras into single connection. They combine the features of other interfaces and provide you with more options for quick implementations. First one is Cci2 Hdmi. Using this converter, you can extend the maximum cable length from 30 centimeters to over 10 meters which is helpful for situations where cameras are put far away from host, and HDMI cables are more manageable. Second one is Cci2 USB 2.0 and 3.0. Converting it to USB connection can help you test and make high-end cameras plug and play for your applications. This can help you create camera systems that are not only compatible with any hardware, but also are high developer friendly. Next one is Cci2 Hdmi. There are times when you may need to get all the captured data from a camera and output them to a specific interface like SPI, LVDS, or etc. With the proper converters, all these, including reverse conversions, are all accomplishable. Apart from all the above converters, there is also a completely different type of bridge that, instead of changing the signal or outputting to other interfaces, either combines multiple Cci2 cameras into a single cable connection or splits a Cci2 camera interface into multiple ones. MIPI Cci2 merger or multiplexer can help you use multiple cameras on hardware with only one camera port. A synchronizer can make sure that all cameras work at the same time, which is a critical factor for a wide range of stereo vision applications. That was all. Thank you for your attention.